Okay, let's continue. We're looking at the 645 quiz preview in Apex. I'm going to work out the B problems with you. 1B says the volume of a cylinder is 54 pi centimeters cubed. If the radius is 3 centimeters, what is the height of the cylinder? Remember, if I write things down on the paper, you need to be writing them down too. Or you could do the problems and then check them by watching the video. So we are talking about a cylinder here. Let's write that equation again. Cylinder formula is V is equal to pi r squared h. And let's see what they've given us. It tells us the volume of the cylinder is 54 pi. So I'm going to put that in the place of V. And it also, if you scroll up, I'm going to scroll down, it tells us, it doesn't tell us to use 3.14. We don't need to because you'll see why in just a second. Okay, so I'm just going to write pi. The radius is 3, so that would be 3 squared. The h is, what is the h? That's what they want us to find. They want us to find h. So how would you solve this for h? Let's simplify this just a little bit. What is 3 squared? It's 9. And all these things are just being multiplied together. But we want h to be by itself. So how do you get h by itself when there's multiplication going on? You divide by the things you want to get rid of. And you have to do it on both sides. So let's see what cancels out. On the right side, the pi's and the 9's cancel out. So we're left with h. What about the left side? Pi's cancel out. Pi divided by pi is pi. They don't have to be straight underneath each other. 54 divided by 9 is 6. So that answer is 6. And remember, the order of these, this A, B, C, D, may not be the same order it's in on your paper. And I meant to have it not showing the answers, although I will give you a copy of the answers so you can check them. I know it's a little bit too tempting to look at the answers at first, so I'll take away that temptation. Okay, let's look at 2B. For 2B, what shape are we talking about here? We're looking at a cone. And let's write the volume formula for a cone. Volume is equal to 1/3 pi r squared h. Let's see what information they give us. Find the height, so we're finding h again, of a cone with a diameter of 12. Okay, if the diameter is 12, then what's the radius? It is 6. The radius is half of whatever the diameter is. Okay, so our radius is 6, whose volume is 226 meters cubed. Use 3.14 for pi and round your answer to the nearest meter. In other words, the nearest whole number. Okay, so let's plug in the information that we know. Volume is 226. It told us to use 3.14 for pi. The radius is 6, so 6 squared, and we are solving for h. So 226 is equal to, let's find out what this is equal to so we don't have to write it over and over. I don't have Desmos open up right this second, so actually, can I pause this? I think I can. Alright, so we're going to put this in Desmos. Open up the keypad here, and I'm going to put 1/3 in parentheses, 1 divided by 3. Don't put close parentheses because it'll just put it around the 3. Just click over here and open up another set of parentheses and see it closes it for you. Times 3.14, close the parentheses, open the parentheses. What is 6 squared? It is 36. So you could either put 36 or 6 squared because they're equal to each other. So what does that equal? 37.68. That's not bad to write, so we can just use all those numbers. 37.68. Don't forget to bring down your h. So what do you do to solve for h? Divide by 37.68. And then in Desmos, we will do 226 divided by 37.68. And we're going to round to the nearest whole. So 5.9 rounds up to 6. That cancels out. H is equal to 6. Okay, let's go back to Apex. That answer is 6B on my screen. I'm not sure what it is on yours. Find the volume of a cone with a diameter of 12 meters and a height of 6. So we are finding the volume of a cone. So for 3b, let's write this again. Cone volume is equal to 1/3 pi r squared h. We're finding volume. Let's rewrite our 1/3. Does it tell us to use 3.14? It does not tell us to use 3.14 because look at your answer choices. They still have pi in them. So you're just going to leave pi as pi and you're not going to multiply anything by 3.14, and I will show you what I'm talking about. Again, it tells us the diameter. The diameter is 12. That means the radius is 6. So 6 squared, and we know the height this time is 6. Okay, so we're going to multiply together the things that we can, the numbers. Pi is a number, but we're going to leave it in terms of pi. We're going to multiply 1/3 times 6 squared times 6. So in Desmos, again, I'm going to put 1/3, 1 divided by 3. I'm going to put that in parentheses. Oh dear, what all just happened there? Let's try this again. 1/3, and click on the other side of the parentheses, times, I'm going to use the times button this time, times 6 squared, or you could put 36, times 6. Oh, I don't know why I did that. I don't have to hit the equal sign. It tells us right there, 72. So 1/3 times 6 squared times 6 is 72. Just bring the pi down. So let's look carefully at these answer choices because they can be a little tricky. There's 2 answer choices that have a 72. But what do we have over here that it equals? It equals 72 pi. So C would be your answer. 72 pi meters cubed. Remember, the units are cubed because this is volume, and volume is cubed. Okay? Don't forget you can pause the video if it feels like I'm ever going too fast. It's my version of saying, does anybody need me to wait? But I don't need to ask that because you can just pause the video. Okay, let's go down to 4b. The cylindrical part of an architectural column has a height of 325 centimeters and a diameter of 30 centimeters. Find the volume of the cylindrical part of the column. Use 3.14 for pi and round your answer to the nearest cubic centimeter if needed. Okay, so what do we have here? We have a cylinder. Let's write down the formula. Volume is equal to pi r squared h. And let's fill in the information that we know. Do I know the volume? Do they tell me the volume? What is it they want us to find? Find the volume. So no, we don't know volume. It tells us to use 3.14 for pi. So instead of writing the pi symbol, we're writing 3.14. It says it has a diameter of 30. The diameter is 30, so that means the radius is what? Half of 30, which is 15. So 15 squared, and the height is 325 centimeters, 325. And then we simply have to just put this into Desmos. Okay, so I'm not going to use any parentheses this time. 3.14 times 15 squared times 325. 229,612.5. Let's look back and see if it tells, round your answer to the nearest cubic centimeter, so the nearest whole number, which is just going to be 229,613. Because this 5 right here makes the 2 move up to a 3. Okay, we got one more, 5b. A TP is designed to have a diameter of 10 feet and a volume of 336 feet cubed. At what height, so we're trying to find h, should the support poles cross to assemble the TP correctly? Use 3.14 for pi and round your answer to the nearest foot. In other words, the nearest whole number. Okay, we're looking at a TP-shaped tent, or it is a TP. But what is that shape? It is a cone. Let's write the volume formula for a cone. Volume is equal to 1/3 pi r squared h. Okay. A diameter, I'm looking at the very top line again, a diameter of 10, so that means your radius is 5. Has a volume of 366. Let's fill that in for volume. The volume is 366, not 336. 366. Do they tell us to use 3.14 for pi? Yes, they do. Times r squared, so that's 5 squared, and we are asked to find h. So let's do that. 366 is equal to, go to Desmos and put this in parentheses. I'm putting my 1/3 because it's a fraction. That's why I usually put that in parentheses. Times 3.14 times, what is 5 squared? It's 25. Okay, so if we round that, let's round it to the hundredths place, 26.17 h. Then what would you do to solve for h? Divide by 26.17. And let's see what that is. 366 divided by 26.17. We're rounding to the nearest, what are our units here? The nearest foot. So the nearest whole number would be 14. H is equal to 14 feet. Now that's not cubed because it's just the length of the height. Height is just 14 feet. Okay? And I believe that's all. I'll give you 5 questions here. All right. Here we go. Be prepared when you come to class, please, and we'll work on this when you get here.